Hello again. We are moving on with our discussion of exponents and exponential functions. We're going to talk specifically about exponential growth and decay and what those mean, because there's a lot of real-life applications to both of those. Think back to exponential functions. They were y equals b to the x, some number raised to the x, and that was set equal to y. In order to calculate y, what you would do is just multiply b by itself a whole bunch of times. If b, that base, is greater than 1, if you keep multiplying a number that's greater than 1 by itself over and over again, the number is going to get bigger the more you do that. But if you have a number that's between 0 and 1, like a decimal or a fraction, that's going to get smaller the more you multiply it by itself. So the value of b determines whether the y's get bigger or whether they get smaller. So that's the difference between growth and decay. A base that's greater than 1 is going to resemble growth, and a base that is between 0 and 1 is going to resemble decay. So if I have something like y equals 1.73 to the x, since 1.73 is bigger than 1, that's going to be a growth function, but something like 0.45, since 0.45 is between 0 and 1, that's going to represent a decay function. So just a distinction there that you need to be aware of. If I have percent growth and decay, and there was something similar to that when we talked about Karen trying to save up for her trip. A is the initial amount that you are investing or that you have. It could be a population, it could be a money amount. R is going to be the rate of growth or decay, and that's expressed as a percent. Then if the thing is growing, then you're going to plug A and R into that function right there, leave X and Y the way they are. Okay? If there is decay instead of growth, then all that changes is that the plus becomes a minus. Okay, so let's look at some examples of this. So let's say the population is 3,000 people, and it grows at a rate of 5% per year. Well, then the growth function would be that 3,000, that's my A, and then 1 plus my rate would be 1 plus 5%, which is 1.05, and so that would be my growth function. If the population decayed at 5% per year, then I would still start off with 3,000, that's my A, but then inside the parentheses I've got 1 minus 5%, which is 1 minus 0.05, that's 0.95. And you'll notice that in the green function, 1.5 is bigger than 1, and 0.95 is between 0 and 1, so I've got them labeled correctly. 1.05 is for the growth, and 0.95 is for the decay. All right, here's an example. The population of Capel is approximately 45,000 people. If the population grows at a rate of 3% per year, how many people will there be in 7 years? Well, my initial amount is 45,000, so I'm calling that A. The rate of growth is 0.03, that's 3% as a decimal. And then X is going to be 7 because that's how many years have gone by. So that's my function right there. Y equals A, 1 plus R to the X. That's the standard function right there for growth. So I just replace A with 45,000. I replace 1 plus R with 1.03, and then X becomes 7, and that is 55,344 people. All right, now let's talk about compound interest. If A is the initial amount that you invest or that you borrow, and R is the interest rate, and N is the number of times interest is calculated per year, because it's not always calculated each year. Sometimes it's calculated every 6 months or every 3 months. You need to know how many times per year interest is calculated, and there will be a word or a phrase that helps you figure that out. T is going to be the number of years that you're investing or borrowing that money, and so here's your growth function. Because the amount that you invest will get bigger, and the amount that you owe will get bigger the longer that you borrow it. So let's use that equation to solve this problem. $5,000 is invested at a rate of 8% per year. Okay, it is compounded quarterly. That means 4 times a year, every 3 months. And that's going to happen for 9 years. How much is it worth now? Well, here was my original equation. My A is going to be my initial amount, so that's 5,000. My R is going to be 8% per year, so that's 0.08 as a decimal. Quarterly means that N is going to equal 4. That's how many times interest gets calculated every year. And T is the time in years. That's 9 years. Okay, so I plug all of those things in, and that's what my equation looks like. All of my numbers are on the right, so I can just simplify all of that in a calculator, and I get $10,199.44. So if I start off with $5,000 and all of that stuff is true, I'm going to have more than double my money when 9 years is over. All right, so that is exponential growth and decay. If you have any questions, please let me know, and I will see you tomorrow.